Okay, this one I'm going to review number 23 on your lecture review. So number 23 is asking how many molecules of water are in 240 grams of water. So 240, and do notice there's a dot there in grams of water, and it wants to know how many molecules of water. And it wants it to 3 significant figures. So if you notice right now, because that decimal point is there, we have 3 significant figures. So we want to make sure our answer ends up with 3 significant figures as well. So first thing we need to do is we need to convert from our grams of water into moles of water. So if you did number 22, this is kind of the same step, except you would stop after this conversion factor. So we're going from grams to moles. So you're going to use molar mass of water. So we have 2 hydrogens and 1 oxygen. So that is 18.02 grams in 1 mole of water. So the grams are going to cancel out, and we're going to be left in moles. Now, because it's asking how many molecules of water are in this particular sample of water, now we need to use something called Avogadro's number to go from moles to molecules. So if you remember, Avogadro's number is 6.02 times 10 to the 23, and that is particles in 1 mole. So remember, particles can be ions, atoms, formula units if we're talking about ionic compounds, any type of piece of a whole. So in this case, we're looking at how many water molecules we have in this many grams. Okay, so 1 mole is going to be 6.02 times 10 to the 23rd molecules. Get a little far away from me. Okay, and then again, you're just going to multiply across the top and divide by what's on the bottom. Now, when you type in the 6.02 times 10 to the 23rd, use the double E button if you have it, or an exponent button. So we have 240 times 6.02, and I have a scientific calculator, so if you notice, it's right here is the double E. So I'm going to hit second, and then it should show up with just an E, and that means times 10. So I don't need to do anything else. 23. So there's my 240 times 6.02 to the 23rd, and then I'm going to divide that by 18.02. Now, when you do that, you get a really long number. We only want 3 significant figures, so we're going to count 3 figures over. So it starts with 8. So there's 1.0. There's 2. And then I have a third one that I need, so I need to round that. Well, this is 0.01775, etc. So there's a 7 after that 1, so that means it needs to be a 2. It needs to round up. And then if you look, I have times 10 to the 24th. And that is going to be molecules. I'm going to go ahead and do number 24 while I'm at it because it's the same setup, and then it's just one more step. So now that I know I have this many molecules, number 24 is asking how many total hydrogen atoms are there? Well, I know that in H2O, how many hydrogens are there? There are 2 hydrogens. Okay, so if I have this many molecules of water, what do I need to do to find just hydrogen? All I'm going to do, multiply that number by 2. And you can do this as a conversion. Okay, so we have our 8.02 times 10 to the 24th molecules. And then 1 molecule has 2 hydrogen. Okay, so 8.02 to the 24th, and then just times 2. And that gives us 1.6, and then it's 1.604. If I put that 0 there, because of the decimal point, that makes that significant. Times 10 to the 25th. And that is how many hydrogens there are.